Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the quadratic relations part of the course. It's question number 10 of a series of word problems that I've assigned. Let's go ahead and look at the question. Question 10 says, the bridge on the right, so in this case the bridge below, has a steel support arch that is parabolic in shape. So it's emphasized here in the darker ink. That's clearly a parabola. The span of the bridge, so the span of the bridge, it says from point C to D is 350 meters. So let's add that to the diagram, that going from C to D is 350 meters. The roadway where points E and B lie, so this roadway up here is 20 meters above where this bottom span lies, and point A is another 15 meters above that. So that's important because now we have a whole bunch of information about where these different important points are going to lie with relation to each other. And for example, if we do the symmetry and cut the parabola in half, instead of saying 350 meters from C to D, we could talk about 175 meters here and 175 meters here. So there's now lots of information about this parabola, and let's see what we're supposed to do. It says using point A as the origin point, write the vertex form of the bridge. So origin point means on the xy coordinate plane, that's the center where the two axes intersect. So we're going to basically throw a Cartesian plane on top of this parabola, and you can see the parabola here, and try to find the equation. So let's clean up my little diagram a bit, and we'll shrink this picture, and we'll try to make a better picture to help us answer this question. So where's my eraser here? So let's go ahead and draw a pretty decent picture to help us understand. Again, the origin is where the x and y axis intersect on the Cartesian plane. And so what we're going to do is we're going to redraw this parabolic arch. But again, we want point A to be here. So that would mean it would look something like this. We don't need to be perfect. We just want to make sure that we get point A and we see roughly what's happening. So here's point A, and that happens to be the vertex. So we actually know exactly where the vertex is. It's at 0, 0. And we're supposed to write the vertex form of the equation. So if you remember, the vertex form of a quadratic looks like this, where H and K come from here and here in the vertex. Well, if this is 0 and this is 0, I'm left with the following equation. So really, all I have to do is figure out the A value for this parabola. And in order to do that, I need one other point other than the vertex. So there's lots of options here. But again, using the information I was given, I could, for example, talk about the point, oops, let's get a different color, right here. So we know that from here to here represents the span from here to here. And that was 350. So half of that is 175. So this point here is over 175 and down. Well, let's figure that out. How far down do I go to get to this point? Well, this is from point A down to the road and then down to the bottom of the bridge, or to the water's level, which was down 15 and 20 more according to the information in the question. So if I go down 15 and down 20 more, I'm down 35 meters. So this point here would be at 175, negative 35. So that's the point I'm going to use to solve for A. And again, I needed any other point, and that point happened to me to be the easiest one to find. So let's go ahead and sub into the equation the values of x and y that we just found. So y is negative 35, and a is, I don't know, x is 175. So I'm going to square 175, get a reasonably large number, I guess, 30,625. And then to solve for a, I need to divide both sides by that number. And so go ahead and get a decimal here. But let's keep a lot of significant digits just so that we can really make sure that we're getting a similar answer, or in fact the exact same answer later on. So the decimal value I get is 0.001143. So let's say that that's, oops, and I didn't write down what I said, did I? 0.001143 is the A value. So that gives me this equation. Oh, it was negative, right? Don't forget that. That's not a small mistake. That's a pretty significant mistake because it's clearly a negative parabola. So there's my equation in vertex form. I realize it doesn't look a lot like vertex form, but that's because it would be pretty silly to have to write this. X minus 0 squared plus 0. That would look funny, and it would be a waste of ink. So we don't write the minus 0 plus 0, we write like this. And in fact, I'm also supposed to write it in standard form. So if I want this in standard form, y equals ax squared plus bx plus c, well, again, we don't write that. It's actually already in standard form as well. So it's kind of nice that this is both vertex form and standard form. So that was the first part of it. Now I need to redo this question, but now we want to use B as the origin point. So think about what that would mean. So now I want this point here to be the center of my XY axis. So think about how that would move things and shift it. Obviously my vertex is not at 0, 0 now. So let's shrink this a little. Oops. Hey, little guy. I can move too. And let's try to redraw this. And again, this time, what's going to happen is that if this is my origin, then my vertex is going to be up here a little bit. So my parabola is going to look more like this. Ooh, pretty nice. Thank you. So now where is my vertex? Well, x is 0 because it's just straight up. But how far up is it? Well, it's 15 meters up. So my vertex is at 0, 15. So I can go ahead and start thinking about the vertex form of my equation. So x minus 0 squared plus 15. And again, we really don't write x minus 0, so it really looks like this. So now I need to find a. Now, I hope you already know what a is supposed to be, but I'm going to pretend I don't know. And that's important because I'm hoping you know what the right answer is, but just in case, let's go ahead and do a little bit more math than we need to. I need to find A. In order to find A, I need another point. So using again the information, what's another point? Well, for example, I don't really know where this point is, do I? Do I know where this point or this point is? Not really. But I can talk about this point fairly well because I know that that point is, again, 175 meters from that center line. So over 175. In this case, instead of going down all the way from the top, it's only down from the road work. So it's only down 20 meters. So my x and y are going to be 175 and negative 20. So subbing that into the equation, and then I'm going to solve for a. So subtract 15 from both sides, and it should start to look very familiar to you. Negative 35, 175 squared. In fact, 175 squared is 30,625. And then again, this looks really familiar, right? So let's see how familiar. You should get negative 0.001143 for A. Now, why is this so familiar? Well, it's exactly the same A value that we got in the last, sorry, so the A value is exactly the same A value that we just calculated. And that makes sense. Just because we're moving where the vertex is, we're not changing the shape of this parabola. That parabola has the exact same shape, and it's the a value that dictates the shape of a parabola. So we didn't need to do any of the math we just did. Once we knew where the vertex was, we should have known that the a value was exactly the same a value because it's exactly the same shaped parabola. So this is what my parabola looks like if I'm writing it both in vertex form. Remember that it's +0, so we don't have to write it. And this is also in standard form because it's ax squared plus bx plus c. So there it is in both vertex form and standard form. And remember this value? We're just going to go ahead and use that value in our next question. We're now going to use C as the origin point. So here's C. So C is the origin. So again, imagine putting the xy axis, and here's my vertex. So let's go ahead and draw this up a little nicer, just so we can make sure that we're making sense of everything. We'll shrink this down a little bit. I'll draw the nice axis lines. Ooh, that didn't work out so well. Axis lines. And again, this time, look where C is. C is over here. So this time my parabola is going to look like this. It's going to start here, and it's going to go up and then down like this, because C is right here at this bottom corner. So this time, where's my vertex? So my vertex is here. And what is the value of that? So how far over and how far up? Well, we know that the vertex is over 175, and we know that it's up 20 plus 15. We know it's up 35. So we can write y equals a x minus 175 squared plus 35. And then how do I find a? Oh, wait, I don't have to find a, do I? I know that the shape is the shape is the shape. So I know already that that's my a value. And I don't need to recalculate it. But again, if I did want to, I could use easily the 0.00 and sub that into the equation. So there's my equation in perfect vertex form. If I wanted to write it in standard form, I'm going to have to FOIL or expand that binomial squared. Oops. So x squared minus 350x plus 30,625 plus 35. So y equals, it's going to get ugly, and I don't know why someone would want this, but what the heck? We were asked, so let's do it. So 350 times our a value is pretty close to 4, so let's call it 4. So plus 4x, and then 3625 times our a value is, ooh, sorry, 3625 times our a value is basically 35. And then collecting like terms, this is my equation in standard form. Does it make sense that there's a +0 at the end? Absolutely, because +0 means that that when x is 0, so is y. Okay? And there's one more question, I think. Same idea. Now we're going to use point E as our starting point. So if point E is our starting point, where's the vertex? Again, over 175, up 15. So we would have this equation. So 175 is because sideways to the right by 175, and up 15. And you could use this point or this point as your check to make sure that it's the same A. But of course, we know it's the same A because it's the same shape parabola. So I hope that that helps. An interesting question indeed. And again, if you're driving around, have a look for bridges like this. I've seen them everywhere. And that's it for video number 10.